Alright, so today we are starting to talk about the unit circle. So a unit circle, what that means is it's a circle with a radius of 1. So a unit circle is a circle with a radius of 1. Yeah, the board's bad today. So since the radius is 1, that makes right here, that's the point 1, 0. Up here is the point 0, 1. Over here is the point negative 1, 0. And down there will be the point 0, negative 1. So what also happens is we're going to be drawing our triangles like we've been doing lately with our angles, and we talked about our reference angles before. So we're going to be drawing our triangles within the unit circle. So what happens with that is that makes your hypotenuse always is going to be a 1, because your hypotenuse ends up being one of the radius of your circle. So then if we're given a point, like the point x comma y there, remember that side is your x, because that's how many spaces you move over for your x. Our up and down is our what? Is our y. So since the hypotenuse is 1, that means your cosine of your angle is just going to be x. So whatever the x value from your point is, that's going to be your cosine value. Our sine value would be your y. And so then our tangent is y over x. So whatever the y value is from your point, you put it over your x. Now other things we've already talked about before are still true. This line over here represents 0 degrees and 360 degrees. Up here represents what? 90 degrees.
Cosine of that angle, it would be like x over 1, right?
Which is x.
Oh, yeah.
Yeah. Over here is 180. And then down here would be our 270. So those still all hold true. Another thing that still holds true is our all schools torture children. You guys remember what that stands for? This means all of your trig functions are positive in your first quadrant. Which one is positive in the second? Your sine. The other ones are all negative. Down here, which one's positive? Tangent, and then your cosine. So all those rules are still true. Nothing has changed. All we've done is we're putting all of our triangles, we're just kind of shrinking them down so that they fit within this unit circle so that your radius is always a 1. So what ends up happening then is if you get a problem like this, it tells you that point P, those are your coordinates right there of it. It lies on a unit circle, so we know it fits within our picture up here. They want us to find sine, cosine, and tangent. So since they told us this is on the unit circle, that means our x value is our cosine, and our y value is our sine, because it's in the unit circle. So sine of theta would be 12 over 13. Cosine of theta would be negative 5 over 13. The one that we actually have to do a little bit of work for in order to find would be your tangent. So looking at our box up above, we said tangent was what over what? Y over x. So our y is 12 over 13. And that's going to be over our negative 5 over 13.
How do we know that when it's going to be negative 5 over 13 and 12 over 13, how do we know that those make up sine and cosine?
Because of the unit circle, your x is your cosine, your y is your sine. Every single time. So we have to clean this up. We can't leave this like this. So our tangent, we got to do keep, change, flip, 12 over 13 times 13 over negative 5. What happens with our 13s? Cancels. So our tangent ends up being 12 over negative 5. Okay, so then looking at our quadrantal values, remember those are the ones that actually line up on your axes, so our 0, 90, 180, 270, 360. It works the same way. So if I'm looking at 0 degrees, I'm looking at the point 1 comma 0. So my x value there is my cosine, so that means my cosine of angle 0 would be a 1. My y value is my sine. So our sine for that angle is 0. Our tangent, again, is y over x. So it would be 0 over 1, which ends up equaling what? 0. Which other angle is that going to be true for? 360. 360 and 0 are going to be the same. So then if we look at 90, our x value at 90 is what? 0, so that means our cosine of 90 is a 0. Our sine of 90 is going to be a 1. So then our tangent, y over x, would be 1 over 0, but what does that equal? No, that equals undefined. You can't divide by 0. So the tangent value for 90 is undefined. So let's do our 180. What is the x value of 180? Negative 1. So our cosine of 180 is negative 1. Our sine of 180 is 0. Tangent is y over x. So 0 over negative 1, which is 0. All right, so then our 270, our x value is 0. So our cosine is 0 of 270. Our sine of 270 would be negative 1. Y over x makes our tangent value what? Undefined. You need to know those. But what the other thing that ends up happening with our unit circle is all of your values are going to be in between negative 1 and positive 1 because it's within the unit circle. So your quadrantals, that's where you're going to get your low and your high. So negative 1, positive 1. So if they try to ask you to find like the sine of 1.5, you can't do that. It's got to be a value between negative 1 and positive 1. So let's take a look at our questions down here. They want us to evaluate these. So for our first one, sine of 90, we look at our chart. What is the sine of 90? 1. Plus the cosine of 270. What is our cosine of 270? 0. So 1 plus 0?
1.
Squared? 1. All right, our next one, 2 times the cosine of negative 180. But negative 180 is really the same as what? Positive 180. Ends up being the same place when you go around your quadrants, remember? If I want negative 180, it's still going to end up there. So then what's our cosine of positive 180? Negative 1. It's going to be the same thing. And then plus 3 times the tangent of 360, which tangent of 360 is 0. Because your terminal side is the same. So 2 times negative 1 gives us negative 2 plus 0. We get negative 2. And then our last one down there, what are we plugging in for our theta? 90. They told us to plug in 90. So we're doing sine of 90 over cosine of, what's 2 times 90? 180. So we'll look at our chart. Sine of 90 is 1. They told me to plug in 90. Cosine of 180 is?
So we're plugging in after that symbol?
Yes, this was a typo. So we get a negative 1. You should know and love that chart.
So basically just try to memorize that cosine of x.
Well, they follow
y,
patterns.
And then tangent will just be y over
Yeah.
x. And then we'll get to graph.
Or you could always sit there and just draw yourself a quick little unit circle. 90's up here. That's the 0.10. Okay. I can get them that way. All right. So continuing on with our unit circle. So within our unit circle, we use these special right triangles that you guys did last year in geometry. Oh, that's a little too far. So we've got our 30, 60, 90. 30, 60, 90. And then you had your 45, 45, 90. Let's see what you guys can remember. Who remembers the sides of our 30, 60, 90? Oh, your geometry teacher is going to be so mad right now.
Yeah. Probably call me dumb B word.
Oh, there is a square root of 3 involved. Square root of 3, 1, 2. How about for our 45? No, there's one radical. 1, 1, square root of 2. So what's happening is now we are taking those two triangles and we're just kind of shrinking them down so that they can fit within our unit circle. So let's say I'm going to blow this up a little bit so I can write better. This is our 30. Obviously, here is our 90. So if I'm looking at my 30, 60, 90 right triangle, this side needs to change to be a 1 because I'm in the unit circle, which means my radius is a 1. I can't change that. Normally, my side opposite my 90 is a what? 2. So what did I do with that? I shrank it in half. So all my other sides are going to shrink in half. So the side opposite my 30 is going to become 1/2. And the side opposite the 60 becomes the square root of 3 over 2. So what that means is this point right here where your angle reaches your unit circle, because I had to shrink it in half, that becomes the point square radical 3 over 2 comma 1/2. So then going off of what we were talking about on the first page, the cosine of 30 is what? Cosine is your x. So cosine of 30 is radical 3 over 2. What would our sine of 30 be? Yeah. Sine of 30 is 1/2. So then our tangent of 30, again, is our y over our x. But can I leave it that way? No. I can't leave a fraction over a fraction. So we got to do our keep, change, flip. So 1/2 times 2 over the square root of 3. No, what happens with our 2's? Cancel. So my tan of 30 is now 1 over the square root of 3. Which, can I leave it like that? No. No, you can't. So our final answer is the square root of 3 over 3. That's our tangent. So what's going to happen going forward is they're going to ask you to find the exact values of these different numbers. So the exact value of the cosine of 30 is radical 3 over 2. They don't want to see the decimal point 0.866. Sine of 30 is 1/2. Tangent of 30 is radical 3 over 3. So you got to memorize these. Okay, let's go over to the next one here. So in here at the corner is our 60. There's our 90. The other one's 30. So we're still dealing with the same numbers. Just they're going to flip a little bit. So our radius is still a 1. The side opposite of our 60 would be radical 3 over 2. I got to shrink it in half, so I got to divide it by 2. The side opposite our 30 would become 1/2. So really, the point that we're dealing with on our unit circle is the point 1/2 radical 3 over 2. So based off that, what would our cosine of 60 be? 1/2. Cosine is our x value. So cosine of 60 is 1/2. Sine of 60 is our y value, radical 3 over 2. Tangent of 60 would be radical 3 over 2 over 1/2. Which we all know we can't leave it that way. Radical 3 over 2 times 2 over 1. It would just be radical 3 because our 2's cancel. So tan of 60 is just radical 3. So again, you're going to have to memorize those. A lot of memorizing in this unit. So then for our 45, 90, again, our hypotenuse here needs to become a what? 1. So when we shrink down our radical 2 into a 1, this turns into 2 radical 2 over 2, and that turns into radical 2 over 2. So then our point out here that we're dealing with is the point radical 2 over 2, comma, radical 2 over 2. Radical 2 over 2. Whole bunch of 2's. No, a tangent would not be 0. So our cosine of 45 is radical 2 over 2. Our sine of 45, yeah, because you had to take your 45, 45, 90, and you had to shrink it down so your hypotenuse was a 1. So when you do that, those sides become radical 2 over 2. So then our tangent would be radical 2 over 2 over radical 2 over 2, which anything over itself is a what? 1. So the tangent of 45 is 1. If you did the whole keep, change, flip thing, which you could do, everything would cancel, but when it all cancels, it turns into a 1, not a 0. It doesn't go away. It's still something there. Okay. So with our unit circle down here, again, refreshing our memory, cosine is your x, sine is your y, tangent would be your y over your x. What we do is we take those three triangles we just had above with our 30 angle, our 60 angle, and our 45 angle, and we put it all within the unit circle. Radical 2 over 2. Yep. So here's our 30-degree angle. And then this one would be our 45-degree angle. And then that line represents our 60. So again, all I've done is I've taken those three triangles from above, I put them all in quadrant 1 of a unit circle. I've just put them all together. So where that hits your unit circle again is the point radical 3 over 2 and 1/2. Where my 45 hits the circle, we said was the point radical 2 over 2, comma radical 2 over 2. Again, I'm just getting these from the triangle up above. And then for our 60, what were our coordinates?
1/2 and
Radical 3 over 2. Now there's lots of different ways that you could remember this. What I had one student tell me one time is the numbers all go 1, 2, 3, and then it goes 1, 2, 3 back up, and then you put them all under a radical. It's just the square root of 1 is 1, which is why that one doesn't actually have the radical sign anymore, and then they're all over it too. So there's lots of different ways to remember this. Now what happens is your 30, 45, and 60, we're going to be using these as reference angles going forward. So that pattern right there just repeats itself over into the next quadrant where we get a reference angle there of 30 also. Only this time our coordinates change just a little bit because we're in the second quadrant. Our x value should be negative. So the coordinates there would be negative radical 3 over 2, comma 1/2. And then for our 45, what would our coordinates be? Negative radical 2 over 2, comma radical 2 over 2. And then our 60 also repeats. Negative 1/2, comma the square root of 3 over 2. So then it repeats itself again. Down here in quadrant 3, I would have my 30, and both of them would be negative down here. Because we are in quadrant 3. Your x's and y's are both negative. Our 45 would still be radical 2 over 2. It's just they're both negative. And then our 60. And then where do you think it repeats again? In the fourth quadrant. There's our 30, and your y's would be your negative this time, yeah. So they all repeat themselves. These values are all used over and over and over again. That's our unit circle. It all repeats. All goes around. So down here in the bottom, we have already figured out all these values on the last page. We're just going to fill them in. Our sine of 30, what did we say that was? Sine of 30 we said was 1/2. What did we say our cosine of 30 was? Radical 3/2. And we said our tangent of 30 was radical 3/3. Our 45, that one was kind of the easy one. Sine and cosine were both radical 2/2. Our tangent was a 1. And then our 60 is just basically our 30 flipped. So your sine was radical 3/2 and your cosine was 1/2. And then our tangent was radical 3. 1 second, Emily. You've got to memorize those. We're going to use these a lot going forward. So using our values in our table, we're going to evaluate these different ones. So we have 2 times the tangent of 45. So tangent of 45 is what? So we got 2 times 1 plus the sine of 30 is 1/2. So 2 times 1 gives us 2 plus 1/2 gives us 2.5. So our next one, number 2, that's cosecant. That's one of our reciprocal functions. It's the reciprocal of what? Of sine. So really, let's start with sine of 30 is what? 1/2. So to get my cosecant, I just need to flip that. So the cosecant of 30 would be 2. You could put it as 2 over, no, yeah, but sometimes that confuses people. Just flip it. Just flip. Here we're going to plug in a 90. So that's sine squared of 90 plus the cosine of what's 90 divided by 2? 45. So when it's written in that notation of sine squared 90, that means you find out what is your sine of 90, which we put on our first page of notes. Sine of 90 was 1, and then you square that, which would end up giving us 1. Yep. And then our cosine of 45. Radical 2/2. In order to add these actually together, though, I need to make 1 so that it has a common denominator. So I'm going to rewrite 1 as 2/2, which 2/2 is equal to 1. It's just another way of writing it. So when I go to add these together, we would get 2 plus radical 2 all over 2. That would be our answer for that one. For cosine of 30, be radical 3 over 2. Sine of 45, radical 2 over 2. These two already have a common denominator, so I just need to subtract. So it would be radical 3 minus radical 2 all over 2. You can't actually subtract your radical 3 and your radical 2 because they have different numbers under the radical sign. We have 2 times the tangent of 30. So it's 2 times our radical 3 over 3. So that ends up giving us 2 radical 3 over 3. Remember, when we're multiplying, this 2's over a 1, so you multiply your top, multiply your bottoms. 2 radical 3 over 3. For number 4, we need the secant of 60, which is the reciprocal of cosine. So our cosine of 60 is 1/2. So when I flip that, my secant is going to be a 2. So 4 times 2. Minus our cosine of 180, negative 1. So this gives me 8 plus 1. So we get 9.